Hi students, in this video you will be learning how to derive equations of frequencies of different harmonics in case of a closed pipe. This question is very important for intermediate second year physics. This question was appeared many times in the board exam. First of all, let us see the basics of this topic. What is the meaning of closed pipe? Closed pipe means a pipe which is open from one end, closed at another end. That pipe is called as a closed pipe. So for example, so one side is open and other end is closed. So such pipe is called as a closed pipe. Let us see the basics. Here you have to know the distance between antinode and node is lambda by 4, and in this case three different modes we are discussing. The first one is fundamental frequency, which is known as first harmonic, and second overtone also known as third harmonic, fourth overtone also known as fifth harmonic. And you have to know the diagrams for three of them. For the fundamental frequency, this is the diagram. You can see here in the closed pipe, one antinode and one node is there. As you know, distance between antinode and node is lambda by 4. So here antinode node lambda by 4 we have written. In the second case, that is second overtone or third harmonic. So the waves will be like this. In this case, you can see one antinode, one node, antinode and node. You know that antinode node is lambda by 4. So here total from here to here 1 lambda by 4, from here to here second lambda by 4, and from here to here third lambda by 4. That's why we have written here 3 lambda by 4. In the third case, fourth overtone or fifth harmonic. In this case, the diagram will be like this. So if you check here, so totally there will be 5 lambda by 4. So if you know the names and their diagrams, then the second part of this answer will become very easy. Now let us derive the equations of harmonics in case of closed pipe one by one. The first part is fundamental frequency or first harmonic. So in this case, the diagram will be like this. You can see at the diagram, antinode and node, distance between antinode and node is how much here? Lambda by 4. In case of first harmonic, the waves will be formed in the tube as shown in the figure. The first part is very simple. So we have to write here from figure, lambda by 4 is equal to length of the tube. The tube what we are using here, let the length of the tube is L. Therefore, lambda by 4 is equal to L. From figure we can write lambda by 4 equal to L. From here lambda is equal to 4L. Make this as equation number 1. Next thing you have to know in this derivation is speed of sound formula. That is speed of sound formula. Speed of sound is given by V is equal to N lambda. As we are discussing fundamental frequency, first harmonic, we will represent this with letter N1. Therefore, in place of this N, we will write N1. Make this as equation number 2. Now substitute 1 in 2. In 1, you have the value of lambda, that is 4L. So write here. So what we will get here? Put 1 in 2. So we will get V equal to, in place of N1, N1 as it is, in place of lambda 4L. 4L. Now I am flipping this equation. N1 4L I am writing on the left side, V on the right side. So it will become N1 4L is equal to V. So as we have to find N1 here, so N1 is equal to V. This 4L come in the denominator, 4L. Therefore, the first frequency formula is N1 is equal to V by 4L. Let us see the second part of the equation. The second part is known as second overtone or third harmonic. In this case, you have to remember this diagram. In this diagram, you can see here antinode, node, antinode, node. That means distance between node and antinode is lambda by 4. So keeping that point in mind, here you can see 1 lambda by 4 and node to antinode, second lambda by 4, antinode to node, third lambda by 4. That means total 3 lambda by 4 are there. So we have written here 3 lambda by 4, and this is equal to length of the tube L. Therefore, from figure we can write 3 lambda by 4 equal to L. Here we have to find lambda. So lambda keeping on this side, 4 take on the other side, 4L, and 3 will come down through 3. So lambda is equal to 4L by 3. Make this as equation number 1. Now we have to use speed of sound formula. Speed of sound formula is V is equal to N lambda. In this case, we are doing third harmonic. So we are representing with letter N3. So here I am writing N3. This equation number second. Now put equation 1 in equation 2. Simply what you have to do? You have to put equation 1 in equation 2. In equation 1 we have the value of lambda. That lambda we have to substitute here. Therefore V is equal to N3 in place of lambda 4L by 3. 4L by 3. So we have to find N3 here. So flip the equation. The complete N3 4L by 3 on I am writing on the LHS and V on the RHS. So N3 4L by 3 is equal to V. N3 is equal to cross multiplying here 3 V by this 4L down. So 4L. So the formula is N3 is equal to 3V by 4L. What we can do here, in place of V by 4L, we can replace with N1. Therefore, N3 is equal to 3N1. Let us see the last part of the derivation, that is fourth overtone or fifth harmonic. In this case, you have to remember this diagram. Here you can see the waves and formation of antinodes and nodes inside the pipe. If you check here, antinode node 1 lambda by 4, node antinode 2 lambda by 4, antinode node 3 lambda by 4, node antinode 4 lambda by 4, antinode node 5th lambda by 4. That means total there are 5 lambda by 4 are there, which is equal to length of the pipe L. Therefore, from figure we can write 5 lambda by 4 is equal to L. The same thing, lambda is equal to 4L by 5, we have cross multiplied. This is equation number 1. Now we have to use the speed of sound formula, that is V is equal to N lambda. In this case, N will be N5, fifth harmonic. So N5, make this equation number 2. Now put equation 1 in equation 2. That means the value of lambda we have to write here. Therefore, V is equal to, in place of N5 as it is I am writing N5, in place of lambda 4L by 5. 4L by 5. Now flip the equation. N5 4L by 5 equal to V. We have to find N5. So N5 is equal to 5V by 4L cross multiply. So this is the equation for N5, 5V by 4L. Here in place of V by 4L, we will write N1. Therefore, N5 is equal to 5 N1. So this is the equation for fifth harmonic in case of closed pipe. If you compare the frequencies individually, you can see that N1 is to N3 is to N5 is equal to the value of N1 N1, the value of N3 3 N1, the value of N5 5 N1. So here we will get 1 is to 3 is to 5. Therefore, the frequencies are in the ratio of 1 is to 3 is to 5 in case of closed pipe.